Okay, so this is 10 secrets to secure mobile apps. And basically, we're some of the guys working on the OWASP mobile project. And we'll talk a little bit about that later. My name is Jason, and I work at HP Fortify On Demand. I do mobile research and pen testing and iOS stuff. iOS is mostly my area, as well as web hacking, and I come from a pen testing background. So, and my Twitter's up there.
And my name's Daniel Miesler. Also work with HP Fortify On Demand. So we both work for the Research and Development Group. They're at Fortify On Demand. And my background is also pen testing. So wanted to start off by sort of reviewing why we're even talking about mobile. One of the big things to think about is the traffic increase in mobile traffic. We're talking about a 26-fold increase between 2010 and 2015, so massive increase. We're talking about a device per capita very shortly, and we're talking about mobile payments coming close to $1 trillion very soon as well. The other thing about mobile is that performance is just becoming extraordinary. And the more the performance gets better, the more people are going to use it instead of other types of systems. So using a regular system like a laptop or a desktop is just going to become less and less common. And what that really means is that you'll be able to use your mobile device while you're traveling and doing whatever. And when you need a home system, whatever that means, it actually just means you have a better way to do input, which is a full keyboard, and a better way to have a display, which is on your wall or on a monitor or whatever. But you might not need to leave your mobile device. So this year is the year that mobile traffic is actually going to exceed web traffic. And I think it might have already happened, actually. And what that really means is that mobile will start to be just computing, right? We'll actually need another word like static or sedentary or non-mobile computing for doing computing without a mobile device. And the reason this is so important, obviously, is because wherever the users are is exactly where the attackers are going to go. They're going to go exactly where all the traffic is, all the apps are, and all the activity is. So the other thing about mobile is it's the #1 place for development right now. When you look at web apps, you look at traditional type of apps that have been developed, they've hit a plateau a long time ago, but everyone is trying to get into mobile. People who don't have a mobile app out already feel way, way behind. That was the case a year ago. It's definitely the case now. And the people who are building these mobile apps traditionally are not trained in security. They're often just very niche. This is not all developers who do mobile, obviously, but many are very focused on just the mobile piece and aren't familiar with security at all. And it's really assuming, it's really causing a lot of issues. One of the main issues is that they assume the back end of the mobile application is not going to be viewed by others. And that causes all sorts of issues we're going to talk about.
Cool, so this is OWASP. This is the OWASP Mobile Top 10. There's actually a session on this later on today. This is a project we put together similar to the Web Top 10, where it goes over the 10 most prevalent and risky domains, vulnerabilities in mobile apps. And so I won't waste your time going through all of the categories. Today we're only going to touch on a few of them. But this project is very important. It's very near and dear to our hearts, and we're looking for all kinds of help with it. So if you do any mobile development, if you've ever written a piece of secure code for any mobile platform, if you have ideas on how to make the project better, if you're good at wiki editing, we could really use your help. It would mean a lot to us. It would mean a lot to really the world. If you look for mobile security code snippets, code examples, if you look for guidance, there's very few resources right now. So we're looking for help. And there's more on that later too. So this presentation is the top 10 ways to secure your mobile apps. And so we have about 7.5 domains in here, top-level domains like, store your data securely and transport and stuff like that. But there's more than 10 recommendations. There's a lot more. So, take it as what you will. So the first domain, and it matches the OWASP Mobile 10 verbatim, is data storage. So a lot of the issues that you'll see in mobile apps, especially in the news or any application vulnerability that gets publicized about a mobile app, or if you're on a mobile app assessment team or you're a developer, first thing that they talk about is storing data securely. This means passwords, credentials, private data like text messages that might get handled by the app. We have a whole screen later on dedicated. We probably should have put it at the beginning of the slide, but the types of risky data that your mobile app can handle. So the first thing is, if at all possible, don't store anything. And that's like a pie in the sky kind of thing, I understand, to developers. But if there's passwords or personal information that's very sensitive, don't store it. Keep it effaceable in memory or something like that. Don't put it in a data storage unit like a SQL database or a plist file or something like that. So there are several secure storage functions on each platform. On iOS, the first thing that you want to do is, if you're using small fragments of data for keys or passwords or cookies or session data, you want to use the keychain. We're not giving code level examples because we have so much to go over, but we have a long list of resources at the end that have examples for all of this stuff. But the first one is a lot of people, what they do is they store passwords or secrets or something else using NSUser defaults on iOS. And what this does is it stores it in an XML file that's unencrypted on the file system. So anybody who plugs your phone into a computer can grab that XML file and pull these secrets out of that. So avoid at all costs using NSUser defaults on iOS to store secrets, at least. Configuration stuff, maybe. Preferences, maybe, but definitely not passwords, session tokens, encryption keys, stuff like that. For larger data sets, databases using core data or SQLite commands, when you're gonna use those, you have to make sure that when you instantiate a database on iOS, you call the Data Protection API. And the Data Protection API is a method that will basically apply encryption based on some parameters of the phone. So there's a list of 5 of them. One being no data protection, meaning when the phone is plugged into a computer, you can pull files off of the phone easily. The highest being the file is encrypted unless the application is open. And there's a couple in the middle there. There's one that allows you to basically, whenever the phone is unlocked once, ever in its power on, you can read a file. It's not encrypted. So that's the default one for iOS. So if you instantiate a database with NSManage objects or something like that on iOS, that's the default one that gets applied to the file when it's written to the file system. Is after the phone gets unlocked once, that file is unencrypted until the phone is rebooted. And that's pretty unsafe for most secure data that's stored in a database file. So what you want to do is make sure that you apply NS file protection complete unless open. That's the API level that you want for all high-level security stuff. For Android, for small bits of data like keys and passwords, you can use the Android key store. And just like with the iOS keychain, it's very similar, but when you store stuff in the key store or the iOS keychain, you want to make sure it's a crypted value, it's not a plain text value, because when you're dealing with mobile devices that have been jailbroken or rooted or exploited in some way, they can dump the keychain pretty easily. So you want to make sure you have some kind of encryption routine that just stores garbage data that they're not going to understand. And then for Android, you want to make sure you're not storing in a shared location or a world-readable location. So this is the SD card. And we have some slides on what APIs allow data to be stored on the SD card instead of inside of the application sandbox directory. So this is an example here of just a default core data write for an iOS application. So here, we've basically found the file on the phone, we've exported it out to our computer, it's unencrypted because it had no encryption class on it, and we just strings out the file. And you can see here username and password, and then the password is, please don't store me, bro. So that is how simple it is sometimes to just get passwords out of these unencrypted data stores, and this is an iOS example. This is an example of another way to leak data. This is in another slide that we have called This is basically a content provider in an iOS app or an Android application that's basically queryable from any application. So this was a browser. I think this has been patched already. It might not have actually. This is a browser that basically allows any other app on the phone to query it for the user's browsing history, which can include, session tokens in the URL. It can include post data sometimes and things like that. So here we've just connected to the device, pretended we're another app, and pulled out the history of this browser. So what this did is it basically, all the IPC files content providers have a permission flag in the Android manifest file. So make sure that those permissions aren't set to world readable or world writable. That's what makes this possible. So pointed resources for handling data protection. So there's the iOS data protection classes document, and these slides will be up with code snippets on each data protection class that you can apply to SQLite files or anything written to the file system. There's also a guide on encrypted data using core data. And then there's a third-party project or library called SQL Cypher, which bakes in extra encryption on the iOS platform and the Android platform, basically for SQLite. And then for Android pointed code examples, you can use search secure coding practices for Android. And this project actually is super cool. If you go there, this is what it looks like. They basically wrote in a whole secure code guide for Android applications with links to good code snippets and bad code snippets. And so this is probably one of the industry standards right now for this type of thing. At least that's publicly available for Android applications. So we highly recommend this. And you can see the first one is do not store data or information external on the SD card, which we talked about. They also have one about content providers, which we showed a screenshot of. So this will give you pointed advice on how to fix these problems.
Can you switch so you can see the thing here? Like a larger version?
Maybe. There you go.
Oh,
Is this you or me?
that's one.
Okay, good.
All right, so now we're going to talk about server-side protections, which I mentioned earlier. So a big problem with mobile apps is basically people not taking the server-side seriously and really focusing on the mobile app itself and not realizing it's connecting to a back end. And oftentimes the data that you're worried about is actually stored in that back end, and getting that data out could be a problem if it's not protected correctly. So definitely the most overlooked part of mobile applications, I would say probably over half of the vulnerabilities we find in our practice are server-side, and even more than that, percentage-wise of the critical vulns are server-side. So really serious stuff. Some things you need to do: validate all input. This is standard for any application really, but definitely any web application. And use whitelisting when you can, right? Don't accept things you don't have to. There's another thing is there are a number of open source WAFs and other types of protection that you can use to protect the server side. So definitely you want to look into those. OWASP, ESAPI, those are a couple of options. But look at what's available for your platform and try and use them if possible. You want to have for all your APIs, this is a really important one. A lot of mobile apps are API based, and oftentimes there's no authentication whatsoever. Sort of separate problem, there's not much access control either, so you can just sort of connect directly and pull tons of data out of the back end in a lot of cases. You want to make sure you're authenticating all those requests to your APIs. You also want to have updates on your software, right? You want to make sure the back end is completely updated, and that includes parsing, right? Make sure your parsers are up to date because that's a really big angle of attack. You want to make sure your content type is set correctly so that you can't be tricked with malicious input into consuming and parsing malicious content from an attacker. Setting the content type correctly to JSON or whatever is really going to help a lot in that. The other thing is to use post where you can instead of get. It's just good policy in general, but definitely want to do that. The other thing is try not to cache the content, right? Because when you cache content, now it's being stored, going back to what Jason was talking about, on the device. It'll actually come down the device and stay there to potentially be pulled off later. So try not to cache it if possible. This is an example of a password that you can see was being sent across in a GET. Definitely don't want to see this. Also want to mention this project that Jim Manico is actually leading. Really interesting take on an OWASP project. The OWASP Top 10, as you know, are things to avoid, right? Whether they're risks or threats or vulnerabilities, they're things you're trying to avoid. This project takes the opposite approach and says, what should you be doing, right? You should parameterize your queries. You should encode your data, validate all inputs. So it's kind of what to do instead of what not to do. Really interesting project. We recommend you take a look at it.
Okay, so the next section is encrypting and protecting traffic. So where possible, you always want to use HTTPS over HTTP. And I know this is a performance concern for some of you, but it's really what you need to do. Mixed mode content on APIs just exposes the user, especially on a mobile device, because they might be connected to a network that's not their own or not trusted, is really important. So just disable all your HTTP endpoints if you can. Setting your cookies to secure and HTTP only, saves a lot of headaches and passwords and man-in-the-middle attacks and stuff like that. This is general web stuff as well. Use the proper cipher strength and algorithms for SSL. There was a lot of talk about the types of attacks that can exist in SSL algorithms yesterday by the White Hat guys. It was pretty cool. And then whenever possible, when you're using certificates, you have to use them well, and then also, if you can, use certificate pinning. So certificate pinning, on websites, not that common, but if you do it with a mobile app, it's more common on mobile apps, and it also really messes up an attacker. So, anyone who's ever tested a mobile app, if you've embedded certificate pinning, it can tell you it adds a significant amount of time to disable the certificate pinning, or if it's at all possible. So there's a repository of different platforms, certificate pinning code at that link right there. It's by a really cool consultancy called ISEC Partners. And so they have some plug-and-play code where you can enable certificate pinning. You just bundle your certificate with your mobile app, and it will force the user to connect with that certificate, and if the server gets the API gets a request without it, it will just kill it. So we're going to talk about making the bad guy's job harder. That's actually one of our domains, so that'll have more of that in it. So things that are like poor TLS implementations are trusting any certificate or self-signed certificates or any root of a certificate, allowing expired certificates. These kind of things allow trivial man-in-the-middle attacks or spoofing, since you might be on an adversarial network. Mixed mode is bad, like I said. Don't keep APIs open. You can use an attack like SSL strip to downgrade a connection to HTTP if you still have the HTTP endpoint open, forcing the user to expose their cookies or their passwords over the wire. And then there's a ton of other SSL checks. If you didn't see this link, it came out last week. It's the SSL checklist for penetration testers, but also very useful for developers. It's like the 40 top misconfigurations with SSL certificates and algorithms that you can find. And basically it tells you how to do them manually. So there's a lot of tools that'll do SSL checking for you, like SSLIs, or there's like a Qualys site that does some SSL checking, but they don't all do the same things. And so this has a pointed list on how to actually use OpenSSL on the command line to check for these issues. And these slides are available, so you'll be able to find the link and click it, and then it'll take you to this thing. So, but you could also just Google SSL checklist for penetration testers, or it's on Daniel and I's Twitter as well. So here's just an example of this is doubly bad. This is a password sent over GET to an API, and a JSON-based API, and it's also over HTTP. So don't do this. This is bad. This actually happens in the real world. People do it all the time. And you can see it's sent from an iDevice because you can see CF network is the call and the user agent down there. So just an example. This me?
Yes, sir.
Okay. So the next one is know the operating system you're coding for. So this kind of maps to the OWASP Top 10 unintended data leakage category, but it also maps a little bit to insecure data storage. So, take it as you will. Problems are sometimes similar in those two categories. But take a look at your OS and realize the functions that you might not, well, I guess it's hard to realize what you might not know, but use this list to kind of guide you in what what the OS does that might make your application insecure, even without you knowing it. So on the iOS on the left side, iOS has logging calls. So when you log, these logs are available to all of the apps on the system, as well as any user who plugs the phone into a computer. A lot of people don't realize this. So let's say that you have an application like Facebook, and you've embedded some NSLog calls in it to do debugging or something like that, and you don't remove it before production, and it ships. All of their data on the phone, all the data on the phone can just pull a copy of the logs, and if you've logged sensitive data, it's now theirs. So that's important to remove NSLog calls of sensitive data in production. iOS takes screenshots to background applications. So when you press the home button, what happens is that the OS takes a screenshot of whatever screen you're on. Now, if the screen you're on had sensitive data like a credit card number or something like that, then that application screenshot is now considered sensitive data, and it gets stored on the file system with the lowest data protection API class called on that image. So people can plug the phone in and pull it off as well. URL caching, this is one where basically if you don't have the cache header set correctly like we talked about on the website, all requests that you send to the web server and response data, as of iOS 7, I think it still does response data, will get cached in a database file with the lowest protection API as well. So this is the cache.db file, and we'll show an example of this in a couple seconds. Whenever you use the keyboard on an iOS application, in order to provide you with the autocorrect function of what you might have spelled wrong, it creates a text file with the characters that you've entered. So kind of like a little built-in keylogger. This file is stored on the operating system unencrypted as well. Copy and paste, whenever you copy words, they go into a buffer that's easily pulled off from the phone. And then photo sharing is one that we'll show in a couple seconds. Whenever you take a photo with your camera, you have two options of storing it. One is storing it in the application sandbox directory, and one is storing it in the global photo roll. The global photo roll is accessible to every other app on the phone. So on Android, you have the same thing, URL caching. This happens with the browser API on Android. I forget the name of it, but same deal with iOS. So make sure you set the cache headers right on your website or API. Logging in Android is logd. Same issues. The logs are accessible to anybody. Content providers, when you set up a content provider, like we showed earlier, you have to make sure that it's not world readable and world writable. Storage outside of the application sandbox directory, like external storage on the SD card, this was already mentioned, but mode world read and write, these are bad things to have, and these will be set in your Android manifest file. Web views, so any data stored by a web view using HTML5, these are some CVE examples that have some code that was used in third-party frameworks. So if you're using a third-party framework like PhoneGap or something like that, basically they're handling a lot of this stuff with HTML5, and they'll do HTML5 data storage, and you have to ensure that there's some encryption or that data is being stored in a way that's encrypted. And then inter-process communications like services and broadcast receivers, you have to make sure that they have permissions set on them. And then any unencrypted data or sensitive data stored in the application heap in memory, because if you have a rooted phone, you can pull data out of memory pretty easily. So this is an example of verbose logging for an iOS application. So this was a banking application we did. For debug, they were basically all transactions. They were taking the account, the card number, the description, maybe the check number, any information. All this was going to the global system logs, and any other application on the phone could pull this data out. So this is basically an NSLog call that they left in production. This one is an example of the iOS photo roll thing I was talking about. So basically, a lot of banking applications will do this now, where you take a picture of your check and they'll deposit it for you. A lot of them store it to the global photo roll, which will put that picture of your check along with all your other images, and any other app that you've installed on the phone, what you've said can access your images, can now take this check image out of your phone. So When you're storing check images or any sensitive images at all, they should be stored not using the global photo roll, but using the application sandbox. Just drop them as images into the sandbox. This is an example of the caching we talked about. So if your site doesn't have proper caching control enabled, it ends up in this file called cache.db at the top inside of your application directory. And here you can see there's a whole bunch of data about this. What was this? This was a credit card application and transactions and inquiry details and stuff like this. So this ends up on the file system with either the weakest data protection class or no data protection class on iOS. Cool.
All right, so we're going to talk a little bit about knowing what you're putting into your application. So thing to know about is when data can be pulled off your application or off your mobile device, it's usually dependent, and increasingly so, it's becoming more and more dependent on how much permission you've given various applications on your phone, right? So there's lots of different data you're worried about. You're worried about name, address, your geolocation, device name, email, phone numbers, contacts, application data, sensitive data that you might have entered, credentials you could have entered for various different networks. Based on what you've done on the right here, where it's asked when you first installed, hey, can I do this? Hey, can I do this? When you say yes to those things, keep in mind that you're opening yourself up more and more to data extraction. So one thing to consider when you're looking at your mobile applications, either whether you're testing mobile applications or you're building them, is to use proxies to see what's actually leaving, going back and forth between your app and the back end, and maybe multiple back ends, as we'll talk about. So Charles Proxy is one, Burp Suite is another one.
Zap.
Yeah, Zap is another one. There are a number of options out there, but you just want to make sure that you're actually seeing, what's going on, and these are the tools you can use. So here's an example of some content actually being sent out. This was actually a
This is the LinkedIn app.
yeah, it was LinkedIn, and basically the regular content was working fine between the mobile app and the back end. But in addition to that, there's actually another piece of functionality which was sending this content out, and it wasn't even using encryption. So you really just have to know what you're putting into your app because the functionality you're adding might actually come with other functionality you didn't know you were adding. So sort of an example that we've seen in our practice multiple times is exactly this type of thing that happened to the LinkedIn app. In this case, it was a women's health application. It was a mobile application. It was meant to take in some pretty sensitive information. First of all, you had the credentials for the app, which could be shared, but more importantly, it was sensitive data that was being entered, right? And this data was going into the app, and it was actually protected between the mobile app and the back end. Problem is, they were using an analytics network, which is high traffic, right? Analytics networks take in tons and tons of traffic, so they don't like SSL. So what they were doing is taking a copy of these very sensitive data entries. It was like a diary. And people were putting very sensitive data into it, and a copy of it was going to the analytics network with no encryption. And if you only audited just the main area, you wouldn't cover that. So related to that, we're going to talk about analyzing traffic, network traffic for your mobile apps. So going back to the previous point, developers often assume that their apps are going to be well behaved. They're going to assume that you have your basic client and you have the main backend that it's talking to, and that's probably it, right? Not always the case. You would like to think that, but you need to verify it, and there are tools for doing that. So one thing you can do that we do in our practice is capture all of the data during a session. Capture a full session of you exercising the app completely, and pull that into a single PCAP. And what you can do is actually use TCP dump and T-Shark, and you can actually break this giant PCAP into individual hosts that were communicated with. And what's really interesting is when you show somebody, a developer or a customer, who do you think this mobile app is speaking with? And they say, well, here's the IP address of the back end. You show them the output of this, and it might blow up into 13 different hosts. And they say, well, that's not coded in. How did that happen? And then you have to show all these other avenues that the mobile app is actually speaking through. So once you have this master PCAP, what you can do is you can actually use TCP dump to break the PCAP into multiple PCAPs based on the host. Now you have multiple PCAPs, which lets you do some pretty cool things. So you've already entered sensitive data into the app, right? The data that was entered was credentials. You also entered other sensitive data that was app-related. So maybe it was health information or financial information. Well, what you can do is you can have the clear text of that, but you can also transform it into multiple different types of encoding and then search for all those iterations inside of these individual PCAP files. So if you get a hit on one of them, it's automatically really interesting information. You can also do that same searching on the file system as well for device security. So what's really interesting is now that you know you're talking to all these various hosts, what are the reputation of these hosts? Are they completely unknown to the overall information security community? Does DShield know about them? Are they listed as unknown? Are they listed as benign? Are they listed as malicious? This is really helpful for Android apps, in particular malicious apps, most of which are Android, but not all, where you can actually run the app and actually see the scattering of the multiple connections, and then look at the endpoint reputation and see that a lot of them are actually malicious just off the bat. So you can find your data moving across those various connections, and if you find it going to a malicious one, you automatically have a critical, right? If you see your data going across any of these in any form, it's automatically a finding. And the reason for that, of course, is that encryption was not used, because we're using grep, right? If this was a TCP session that was encrypted, grep would not work. So getting hits from this technique is really a valuable way to learn about your application.
So the last broad level domain we have is make it hard for the attacker. And this was an addition to the OWASP Mobile Top 10 called binary protections, lack of binary protections, and there was a lot of hoopla about it this year about whether it should have been added or not. But we think it's really valuable because the more time you make the attacker waste on getting data out of your app, the less likely they are to continue doing it. Also, the skill level for mobile hackers goes from like super script kiddie and like never done anything before to, and then like there's like nothing in between, and then there's your super elite mobile hackers who are doing like jailbreaks and stuff like that. So, so adding these protections takes care of, maybe like 60% of the population that just wants to crack your app to distribute it on a rogue store or wants to put you in the news for bad encryption. Once you break one of their techniques or tools, they will go away. So on the left side, we have iOS, right? So iOS comes with 3 compiler protection flags that not a lot of people use. Basically enabling ASLR Pi, which is a form of memory randomization optimization. There's stack smashing protection, which is a canary-based memory protection. And then there's using the automatic reference counting memory system for iOS. So those are 3 basically checkboxes and objectives in Xcode that you can just check, and we'll show screenshots of them, and we have links on how to enable them that mitigate a lot of the exploit type attacks that might come against your mobile attack in userland. Then there's jailbreak protection. So jailbreak detection is putting some code in that will basically query the file system or other places to see if the application is running on a jailbroken device. And you don't want your application running on a jailbroken device because the attacker has all the control on a jailbroken device. They can hook into your application, make it do things that you don't want it to do. They can query all the sensitive information. Once they have control of the device, then it's pretty much game over. So you can bake in routines, basically functions that look for certain paths that are installed with jailbreak code, and then kill the app if it finds those paths. There's some other tools too to basically obfuscate your code or add routines to do integrity hashing or stuff like that that are free. So one is LLVM Obfuscator. This is a whole discipline itself that'll obfuscate Objective-C. This, I don't know how this is going to work when Swift comes out, so we'll have to see. IMOS is another project that was demoed yesterday. It was a talk called iOS Integrity, I think. It's a whole project with separate code snippets and routines to do integrity hashing, jailbreak protection. There's one that you can drop in to add a custom PIN to your application to encrypt it twice in addition to your device PIN. They have like 7 or 8 security controls, and I think they dropped some more yesterday. And it's part of the OWASP mobile project, which we're part of. So IMOS is definitely something to look at if you want to add security protections on iOS. Stripping usernames and paths from your application before it goes to production, this is really important, as well as symbols. And then there's another project in OWASP called the Reverse Engineering Code Modification Prevention Project, which gives more information and code snippets about basically defeating an attacker and who's trying to reverse engineer your project, which includes anti-debugging, anti-reverse engineering. So if someone tries to hook up your app to a reverse engineering tool like IDA or Hopper or something like that, or they're trying to debug it with GDB, it will kill those tools immediately or cause them to give output that's just nonsensical. So adding these types of protections to the apps really destroys an attacker. If you added all of these on the left side to an iOS app that we were going to assess, it would maybe quadruple the time for experienced testers to even test your app. I mean, that's pretty accurate, right, Greg? Greg leads our mobile team, so yeah, it's really a pain in the butt, right? Yeah. So on Android, the memory stuff is pretty much taken care of on Android. You don't have to worry about any of the user land kind of extra stuff. It just happens automatically when you compile, so that's fine. For code obfuscation, ProGuard is the free tool to use for Android applications. For obfuscation, DexGuard is the paid version of that, which has some extra functions. You also want to look at integrity hashing checks. Facebook has an extra layer of SQLite encryption in a project they called Conceal that they released last year, I think. I haven't used this before, but I heard it's pretty cool, and it also does some SQLite database optimization, so I would check it out. And then root detection is the same as jailbreak detection. You want to make sure you're not running on a rooted device, and there's code snippets for that in the CERT project that we mentioned earlier. So this is an example of a compiler protection for iOS. So this is a position-independent executable. There's a link for the whole walkthrough on how to do this, but basically we've taken an app and we don't even have to decrypt it to check to see if this exploit mitigation is there. But you basically run a tool on it to see if it's enabled, and if it's not, then that's an issue. This is the same deal with stack smashing protection. Here you can see in Objective-C how you enable it. You go under other C flags and enable FS Stack Protector All. And these are just things in Xcode, right? They're menus that I don't know why they're not enabled by default. They might be on the next version of Xcode. You never know what they'll set as default, but as of now, they're not. So that's making it hard for the attacker.
Yeah, so just a few takeaways. Mobile increasingly is becoming computing, right? Don't store your data if you don't have to. Use the APIs that are available to protect your data on the device. Know what you're adding to your app, because the functionality that gets added could actually harm you. Make sure you're looking at your network traffic. Look at it objectively, see what's really happening instead of what you hope is happening. Look for your sensitive data in that traffic and on the device itself after you run the application. You want to harden your binaries, as Jason just talked about, and don't forget the server side. The server side really matters. It's part of the mobile application. It's a really important part. The other thing is, as Jason said, so Jason's the project lead for the Mobile Top 10, and I'm one of the leaders as well. And we just released the 2014 list, but we're already gathering data for the 2015 list. And it's really important that we get lots of feedback from companies who do testing, from developers, from anyone who can supply data. Because the more data, the better the prioritization of the list is going to be. So definitely, we'd appreciate your help if you could reach out and provide some data around mobile testing. Because iOS 8 came out just, I think, 2 days ago, want to just do a quick little blurb on it. Short answer is that Apple is opening up a little bit in terms of security. The biggest piece is this third-party extensibility component. So cross-app communication is now becoming much more easy. Keyboards, we're seeing third-party keyboards, we're seeing sharing interfaces. You can now share out to third-party components where previously you couldn't do that. Notification widgets now could be third-party integrated. Touch ID, apps like Amazon now have access to Touch ID where they didn't before. CloudKit integration, always-on VPN, some of the security features in iOS 8.
So along with iOS 8, a lot of people ask about Swift because a lot of the APIs we're talking about are Objective-C based for iOS, right? So they're saying, is all this going to change with Swift? Is there any difference? So at the low level, the answer is not a lot changes. The insecure data storage calls are still the same. A lot of the certificate management calls are the same. The only thing that Swift changes for a developer is syntax, but at the low level, the issues still exist. And there's some independent studies already on kind of how this works and some applications you can play with that are completely written in Swift that have security vulnerabilities, which are the same ones we showed in some of these slides. And they're part of the OWASP mobile project as a whole. If you look there, there's a whole bunch of vulnerable apps to teach you how to audit these things with insecure examples of source code. Don't expect to see change anytime soon. Then there's also Android Art. So a lot of people who are doing mobile reversing or attacking mobile applications are really worried about Art because it's going to take away Dalvik. And we're kind of still looking about how this is going to affect the mobile landscape because right now, all of the devices, even if you choose to use Art as your runtime, they still have the ability to use Dalvik. So the applications themselves can still be decompiled and tampered with, and all the API calls are the same, obviously, because it's still Java. But we're still kind of looking into this. We'll probably do a talk on Art pretty soon and how it affects reverse engineering and code modification and protections and stuff like that. So you should look out for that kind of stuff. So we have a whole bunch of projects under the mobile security banner at OWASP. We have the top 10, which we've talked about, which we need your help with. We have the iOS security cheat sheet, which is a testing-focused document. And then we have the iOS developer cheat sheet, which is a developer-faced security document. And at some level, they're all sort of incomplete. I mean, we do our best, but we have day jobs, and if you feel like some of the information we presented wasn't fully baked, or you go to the site and you want to know more about certain things, and maybe you have some expertise, we could really use your help with any of these, as well as anything under the mobile security banner at OWASP. It's he said in the keynote that we're like 5 years behind in America. Well, you can think of mobile apps as like 10 years behind in security in general, because there's just a ton of stuff that people don't know about the platforms. People, like Daniel said, people who are coding the applications don't have any security training, stuff like that. You'll also notice that these 3 links cover, or mostly this talk was a lot of iOS, a little bit of Android, no Windows, no BlackBerry. That doesn't mean there's no vulnerabilities on these platforms. They all have different security functions. They all have different encryption functions. They're all kind of designed around the same principles. And when you're looking at any source code or you're auditing any type of application, you're looking for the same things. It's just we haven't had the manpower to create those projects yet. So if you do any testing or you do anything like that, we could use your help for those platforms. So we're running out of time. So this slide has links. This is what I'd say you paid the most attention to, other than the high-level topics we talked about. These are all the projects that deal with real snippets of code that you can bake into your application: the security testing cheat sheet, the developer cheat sheet, IMOS, the proactive controls, reverse engineering, SQL Cypher. All the binary protection stuff are listed in blog posts that we've written about. I have to blow through this. Secure coding practice for iOS development, and then the X security project is a project that you can bake into Objective or into the IDE for Xcode. You can bake it into Xcode, and it's a secure code scanner for Xcode. We also have a GitHub for mobile tools. We haven't put anything on there up there, but we're going to put some of the tools that we use in our assessment team and our source code team up on GitHub. So check that in the next couple days. Again, we work at Fortify on Demand. We do this kind of stuff all the time. We're really looking to keep engaged with the community. If you guys need help or anything, just contact us. These are some people who helped with information in this presentation. They're awesome. We work with all of them. We really have the best team I've ever worked with in my whole life. So thanks to them for helping. And then this is us, and we can take any questions now. So, thank you.